Hello friends, very good evening. A hearty welcome to my YouTube channel. And friends, in today's session, we are going to study about the development of the lateral surface of a square pyramid, which is cut by two section planes, one horizontal and the other vertical. In the sense, it is perpendicular to both HP and VP, and they meet at the midpoint of the axis. And they say the square pyramid is lying on HP on its base, with two of the base edges equally inclined to VP. So friends, let us start with the front and top views of the pyramid. So I am going to mark the XY line and then mark VP and HP, indicating first angle projection. And here I construct a square of side 30 millimeter, a square of side 30 millimeter, join the diagonals to represent the slant edges, and I just name it as A, B, C, D. A, B, C and D. O is the vertex, and I am going to project all the lines from here, A, D, B and C, and obtain the front view, which is seen as a triangle here. So I am going to join like this, and friends, here these points will indicate this is O dash and this is the edge OB and OD. I can show this base as A dash, B dash, D dash, this is C dash, and this is O1, the center of the base. So I will mark it as O1, O1 dash. This is O comma O1. O is the vertex and O1 is the center of the base. This is how the pyramid looks, friends. And here you should know that height of this is 60 mm. So we have to mark the height of the pyramid as 60 millimeter. So I have to show that and mark A dash here. Okay. Friends, let us assume that the pyramid is not cut by any section plane. And if you draw the development of the lateral surface of the square pyramid, you will have four isosceles triangles having base equal to 30 mm. So friends, here I am going to draw a vertical line of length is equal to true length, and this is the vertex O. What is this true length? You know very well that all the developments are drawn to true size or the actual size or the true measurement. So friends, if you observe the front view, you have in the front view the line O dash C dash, and the corresponding top view for this is OC. Since OC is parallel to VP, that is top view of this line is parallel to VP, this O dash C dash will represent the true length. Likewise, O dash A dash also gives the true length. So both of these are true length line. So this length, what I have marked here, is the length O dash C dash. So friends, taking this as the center, O as center, and radius equal to the true length, I am going to strike an arc here through O center and true length radius. I am going to strike an arc. On this, I am going to mark all the four corners of the base. So all the corners measure 30 millimeter each. So from here I will step off 30, 30, 30, and again this is 30. Friends, I am going to join this to all these slant edges by thin lines to start with. So I will just mark them later on. So let me join all these by straight lines, because the base edges are straight for the pyramid or the base edges. Now friends, let us mark the section plane. So friends, he said it is cut by two section planes. Both are vertical, and one is horizontal and the other one is vertical. The vertical section plane is perpendicular to both HP and VP, and we can add here and passes through vertex, and it is passing through vertex. So friends, let me mark the horizontal section plane at a height of 30 mm from the base. I will call this as section plane 1-1, which is at a height of 30 mm from the base, because it has to bisect that. So this is section plane 1-1, I will call. This section plane is horizontal. There is another section plane which is vertical, and it says normal to both HP and VP. So friend, that will appear in the front view as a line passing through vertex. I'll just mark this as 2-2. So section plane 1-1 is horizontal, section plane 2-2 is vertical, and they meet at the midpoint of the axis. Now friends, let me darken the portion that is retained for development. So assume we are going to throw away this piece and retain the remaining part, which is going to be used for drawing the development. So this is the portion that is left over after this small portion is thrown out. Friends, if you observe the front view of the pyramid, you find none of the slant edges are totally removed after the section plane cuts the solid, and hence you have the choice to start marking of this development either from OA, ROB, ROC, ROD. So let me say I am starting with this OA. This is O, this is A, and the length of this OA is equal to this O dash C dash. This is OA, this is OB, then comes C, D, and again A. So A and A should come together when you fold them together. Friends, let us take the points where the horizontal section plane 1-1 is cutting the solid. Friends, the horizontal section plane is cutting the slant edge OA or O dash A dash at this point. This is the true length. You can simply take this measurement and mark on OA. So say this is OA, and again this point is also OA. So we get these 2 points. Then friends, it is intersecting, or it is cutting these vertical lines at this point. Both OB and OD are cut there. So friends, at the same, because this is not the true length, we have to pass it on to the true length line, either to OA or OC, and take this measurement on OB and OD. Friends, this is OB and this is OD. And finally friends, the section plane is passing through this point, that is, it is meeting here. And if you observe this friends, the line OC is intact, so that is available. And even this OC, this is removed, you have OC, we have OB and OD, all these are retained. So I am going to show them by full line. OD full line, OB full line, and only on these edges, OA, OB and OD, this part is removed. So friends, I am going to join all these by straight lines. So I will join these two, and friends, this portion, what I am darkening that, will give you the development of the lateral surface of this pyramid, and in which you are not going to have this part, that is on OA, this portion is removed, this is removed. So it is not existing there, and this line will exist. Similarly, this portion is not existing, and the line OC is seen in its full length. Friends, this is how you get the development of the part P. If I call this part as P, the development of this is given by this point. There you have to have O dash C dash completely, OB is completely available, OD is also available. I have shown them by full line. This is full line, this is also full line, this is also full line. Friends, This is how the development is obtained. And friends, you remember, since the section plane is horizontal up to half the width of this pyramid, so these points on OA, OB and OD are parallel to the base edges here. That is to say, this line is parallel to this line is also parallel to this. They are parallel, and here all these measurements will have 30 millimeter as the base, 30, 30, 30, because the base measurement is 30. And friends, this is how you obtain the development of P, the portion of this P I have shown here. Friends, I hope the presentation was interesting, and if you like this video, do share with all your friends. Have a wonderful day. Thank you very much.